limiting factors in reactants, and on the end a little bit about solutions. So here we are, limiting reactants. So far we have assumed that the reactants present are in the correct amounts to react completely. But in reality, one reactant may limit the amount of product that can form. The limiting reactant will be completely used up in this reaction, and the reactant that is not limiting is in excess. Some of this reactant will be left over. So, if you're using two reactants in an equation, the one that you have less of is going to be your limiting factor because it limits how much you can produce of whatever you're trying. So, the excess would be whatever is extra or left over. So that is going to be the one that you have a larger quantity of. Here's an ice cream sundae analogy for limiting reactions. So here you have 2 scoops of ice cream, 1 cherry, 50 milliliters of chocolate syrup, and that equals 1 sundae. And then here you have 8 ice cream scoops, 6 cherries, and 100 milliliters of chocolate syrup, which gives you 2 sundaes. So here, where would your limiting factor be? You would think it would be 6 cherries, but in reality, the thing that limits you is the ice cream, because you only have 2, 4, 6, 8. So you can only make 4 ice cream sundaes. So this would be more limited than this, and this even more so because you only have enough for 2 sundaes. So you can only make 2 sundaes because of these factors. So here we are calculating quantities in the limiting reactant problem, amount to amount. So here's your problem. In another preparation of ClF3, 0.75 moles of Cl2 reacts with 3.00 moles of F2. A. Find the limiting reactant. So here it wants you to find out what is the limited reactant. So what is there the least amount of that stops it from making more? So plan. We find the limiting reactant by calculating the amount of moles of ClF3 that can be formed from each given amount of reactant. Use this information to construct a reaction table. So here's our solution. The balanced equation is Cl2 in the gaseous form plus 3F2 in the gaseous form, which gives us 2ClF3 in the gaseous form. So this is how we work that out. So you have 0.750 moles of Cl2, which we got from up here, and then you have 2 moles of ClF3, which we got from here, and then 1 mole of Cl2, which is from here because Cl doesn't have like a big number in front of it, so it's just 1. And that leaves us with 1.50 moles of ClF3 after we cancel out our moles Cl2. And then we go 3.00 moles F2, we multiply that by 2 moles ClF3 divided by 3 moles F2. And so we get this one from this part of the equation, and we get this from this part of the equation, which leaves us with 2.00 moles ClF3 after we cancel out our moles F2. So Cl2 is the limiting because it yields less ClF3. And then we have our reaction yield. So the theoretical yield is the amount of product calculated using molar ratios from the balanced equation. The actual yield is the amount of product actually obtained. The actual yield is less than the theoretical yield. So here's how you'd figure out your percentage yield. So you'd get the actual yield and the theoretical yield, divide them, and then times that by 100, and that would give you your percentage yield. So solution stoichiometry. Many reactions occur in a solution. A solvent consists of 1 or more solutes dissolved in a solvent. So a solution consists of 1 or more solutes dissolved in a solvent. So today I just did a lab with a solution where we were dissolving copper with nitric acid and water. And so we had to throw away our excess solution because it already had a dissolved solvent that was pretty dangerous. So we had to get rid of that because it's already been absorbed into the solution. So the concentration of a solution is given by the quantity of the solute present in a given quantity of a solution. So concentration is something you'd find like in medicine. And then molarity is often used to express concentration. So molarity equals the mole solute over the liters of the solution. And then to shorten that up at the end, it would be M equals moles times the solute L solution. So that's just a few things on solutions in stoichiometry and limiting reactants. So thank you for watching today. I hope you learned a little because I did too.